Today our topic is the enthalpy. What is enthalpy? As we have studied in a previous chapter, uh, nature of electron and their ability to form bond. So if we are talking about the bonding molecular orbital, it means bonding molecular orbitals having electron in a low energy, and bonding molecular orbital electron having low energy. So why when we break a bond, why we give energy? It is because electron present in bonding molecular orbital having low energy. So we want to break a bond, so we must supply energy from system to surrounding in order to break a bond. For a bond to break, the electron and the bonding molecular orbital must energy from surrounding. Specifically, surrounding energy may be in the form of kinetic energy of the system or any type of heat energy. So such type of energy is called here enthalpy. Enthalpy term is generally is used. This term is generally used for exchange of energy from system to surrounding. So we say that if energy is transferred from surrounding to system at a constant pressure, there is a difference between energy in the surrounding and system at a constant pressure. So we will say that this energy is called enthalpy. So enthalpy is actually type of energy which is transferred from surrounding to system. Total heat content of a system is also called enthalpy, and energy which is used from surrounding to system in order to break down a bond at a constant pressure is also called as enthalpy. Enthalpy is represented by delta H. So here what we do if we break a bond, when a bond is broken down, it may be broken down in a two different way. One is if bond is broken down homolytically. When bond is broken down homolytically, what happens? Suppose a single covalent bond is present in X and Y. In a single covalent bond, two electrons are actually present. So when two electrons are distributed equally, each X and Y carries one electron, so it is called as homolytic bond cleavage. And second type of cleavage is the heterolytic cleavage. In heterolytic cleavage, unequal distribution of electron, two electron are transferred toward one atom and other atom become electron deficient, so positive charge is formed on the X and negative charge on the Y. So two type of bond cleavage occurs. One type is homolytic cleavage and other type is heterolytic cleavage. So in enthalpy and bond breakage, when bond is broken down, it may be broken down in two different way: homolytic bond or heterolytic bond. So this is all about enthalpy and bond breakdown in enthalpy. Now next. So when we provide energy and bond is broken down, we are talking about energy is transferred from system to surrounding. This process is in fact is called the bond dissociation energy. In bond dissociation energy, what happened in bond dissociation energy? When we talk about bond dissociation energy, it means bond is going to be broken down. So bond is broken down, it is called bond dissociation energy. What is heat of reactions? When we talk about heat of reactions, it means heat is to be released or is added in reaction is called heat of reaction. When we talk about heat of reaction, it means this term includes two type of processes. One type of process is bond is being broken down in a reactants, and in the second process is a new bond is formed in the product. So in two type of processes, in reactants and products, there is a difference in energy in the reactants and products. So overall we added and sum up the energy and reactants and products. So it is called heat of reaction. So heat of reactions means amount of heat required or released during or after reaction, after chemical reactions. Amount of energy absorbed or released is called heat of reactions. It is called heat of reactions. So when we talk about heat of reactions, it also include endothermic and exothermic process. In fact, these two process, endo and exothermic process, both these processes constitute the heat of reactions. Both these processes constitute the heat of reactions. In endothermic process, what happened, heat is absorbed, and in exothermic process heat is released. As I talked earlier, in reactants, if we are conducting any experiment in reactions, when reactions complete, we have to supply energy to break down a bond in a reactants, and new bond is formed in a product. Energy is released, means energy is absorbed in a reactant and energy is released in a product. So energy absorbed is called endothermic process and energy released is exothermic process. So when these two processes combine together, as added together, as sum up these two processes, overall heat of reaction is formed. So now we will observe the heat of reaction is whether it is positive or negative. So when these two processes are added or sum up, and ultimate product is negative, ultimate energy is negative, so we will say that heat of reaction is negative. So heat of reaction is negative mean exothermic reactions. When heat of reaction is negative, exothermic reactions, and when heat of reaction is positive, then we will say that endothermic reactions. So any type of reaction, endothermic reaction or exothermic reactions, it in fact it involves endothermic and exothermic processes. So these processes add up, sum up, and overall heat of reactions is obtained. So graphically here, these two processes are represented in graphically. First graph is here given. For this graph is representing the exothermic process, and second graph is representing the endothermic process. In these graphically representations, in fact, when we conduct reactions, what to do? In fact, we are talking about reaction coordinate and enthalpy on y-axis and reaction coordinate on x-axis. Graph here representing the reactant and products. Reactants are changed into products. If we see reactants are present over here, means the reactant have sufficient amount of energy, sufficient amount of enthalpy reactants have, and these reactants have to convert it into products. The products are at the lower position. So we say that products having the lowest enthalpy, minimum enthalpy, and reactants have maximum enthalpy. So in order to convert reactant into product, reactant have to overcome this barrier. So this barrier is called, to reach this barrier, reactants have to gain some amount of energy. This some amount of energy is called activation energy. If activation energy, these reactants gain this activation energy, then these reactants may reach up to the hill. When these reactants reach up to the top of the hill, ultimately immediately these reactants convert into product. Just like that, if a person want to climb up the hill, at the top of the hill, when a person climb up the hill and the top of the hill, definitely a person required some amount of energy. So same is the case here. Reactants have to travel to reach the top of the hill. These reactants have to absorb energy, and when these reactants gain this top of the hill transition state, they convert it into products. So this is called the exothermic reaction. Why this is called exothermic? Because reactant have a sufficient amount of energy and product have the lowest energy. means product have lowest energy. In this reactions, products in fact release the energy. When products release the energy, that process is called, that reaction is called the exothermic reaction. So first graph over here representing the exothermic reaction. So this is called exothermic. First graph representing the exothermic reaction. So exothermic reactions mean energy is released. So product possess little amount of energy, minimum amount of energy, because they have released their energy. In second type of graph, in second graph, reactants and products are represented in second graph, and enthalpy and reaction coordinates. This graph is plotted between enthalpy and reaction coordinate. In this second graph, starting material reactants have a minimum amount of enthalpy, and product have maximum enthalpy. Means these reactants have to travel maximum distance in order to, if we talk about a person travel to upward the top of the hill. Similar situation is for the reactants. The reactants have absorb extra amount of energy, much energy, in order to reach this top of the hill, which is the transition state. So activation energy for in this process will be maximum, activation energy maximum. So it is the endothermic process, because in this process activation energy is maximum. Product having sufficient amount of energy, products don't evolve their energy, it possess maximum amount of energy. So it is called the endothermic process. It's all about the enthalpy.